Hello everyone, it's Benny, and welcome back to Building a Better Redstone Computer. Today, I'm a little bit excited, and the reason I'm so excited is because we're starting a totally new part of the computer. We're not going to be screwing around with the ALU anymore, we're not going to be screwing around with the cache. We're starting something totally different. Sort of. You'll see in just a second. Today, we're going to be starting on the control unit. And the control unit's job is basically, it's going to be what allows us to take this big collection of computery hardware and actually create programs for it. Run code, say, hey, do this sequence of actions, and make the hardware actually do it. And we're going to be starting on it in this video. But as I pointed out in the last video, right now we have way too many controls for this thing. We have a ton of different controls for the ALU, tons of different controls for the register. Yeah, look at that. And the cache. And yeah, it's going to be a little bit of a nightmare to control all that. And granted, one of the jobs of the control unit is to simplify all those wires and handle all that advanced wiring so the programmer doesn't have to. But even still, we have enough that if we don't have to handle the additional complexity in the control unit, it'll make our lives easier. So that's what we're going to do. We're going to make just a few additions to the hardware. And technically, they're sort of ambiguous. You could either consider them part of the existing hardware or part of the control unit. But yeah, there's new things, and the whole point is reduce the complexity, reduce the number of controls we need to control the computer without actually, impeding the ability of the computer to do things. Specifically, right now, we have controls to read or write from any combination of registers. We could write from any combination of registers at once and read from any combination of registers at once. But that's a little bit of an unnecessary power. I mean, realistically, we have one data bus. We can't read more than one data at the time and have it do anything meaningful. I mean, technically it does an OR function between them, which I guess could be useful in a few very, very specific situations, but not really. For the most part, it's just making our lives more complicated, probably far more so than it would benefit us in that one very obscure specific situation. So, and same thing for writing. We only have one piece of data going into the register at a time. Sure, technically there might be a situation where we might want to write to more than one register at once. Again, rare, unusual situation. Probably don't want to handle it. So, that's what we're going to be building. We're going to be building a decoder so that we'll only read or write from one register at a time. It'll make controlling this thing a whole lot easier. And we're not really going to lose a whole lot by doing it. So, yeah, let's go ahead, let's get started. So, first problem. When we're building our decoders, we're going to want them to be somewhere around here. But there's this nice, big 8-bit bus going from the cache to our ALU output in the way. So that's right, viewers. It's the moment you've all been waiting for. We're about to rearrange a whole bunch of stuff in the computer, because it wouldn't be a Benny video nowadays without me using WorldEdit to redo half the computer every video. So yeah, what we're going to do is, it's really not a huge change in the grand scheme of things. We're just going to move this bus in a little bit. We're going to compact it a little. It's position 1 and 2. And I'm going to move 2 over. And this is going to create, small problem right there. That's okay, we're just going to block it off, like this. And just like that, our bus can pass right next to our wire, our wires. And there's no interference. So very nice, very compact, about as compact as you can get. I'm also going to change these to, I'm going to keep that block, but I'm going to put in blocks like this. And set this to position 2, sure, doesn't matter. This can be h cost 1, I can expand 1 down. And I should be able to... Actually, I can break this now, because I'm going to stack... Okay, stack 7 down. And cool. And that's just going to give us a little bit more signal strength to work with over here, because as you've noticed, it's going to require redoing this section a little bit too. And I'm going to want to compact this. So, first off, I'll just show you where I want to put it. I'm going to set this to position 1, lie down here, this to position 2, and once again, I'm going to, I don't even know why that block's there, I'm going to move 2, and there, this is where I want it to be. Now, you might notice, hey, Benny, this is a bit of a problem. Because now, this isn't even powering the repeaters anymore. See? It's just doing this. And that's because this repeater is redirecting the signal. If I don't have that redirecting the signal, it goes through just fine. So our next big giant rearrangement, I'm going to take this whole thing, our cache, the part that encodes it into hexadecimal and sends it to RAM, that whole thing, and I'm going to move it down 1 block. And this way, I'm still powering it just like it needs to. It's still busing outwards. But, as you can see, this piece of redstone wire is no longer being redirected by the repeater. So it can go straight through there. And that's just about perfect. The only thing left is we're going to add sort of an L shape. And like this. And you know, of course, I would move it in here or something, but I can't do that without powering the block, and there's... Well, I guess I could do like this to redirect it. You know what? Yeah, I guess that does work, even if it's a really, really crazy way to do it. You know what? I hadn't planned on doing it like this, but now I'm kind of curious. Now I just want to see what happens now. So I'm going to set this to position 1 and 2, expand 1 down, stack 7 down. Yeah, just like so. We now have the repeaters that lead nowhere. It seems really weird and random, but it's surprisingly functional. Yeah, that's actually going to work. Wow. Okay. So yeah, we have that. And cool. So at this point, I think just about everything is rearranged. So we should... Yeah, we have this huge empty gap we can fit our decoder in. No problem at all. So, now that we've dealt with Crazy Benny and his interesting repeaters, our next step is to build the decoder itself. The big thing we're going to need for this is we're going to need a spiral staircase. So I'm going to start building along this way. I'm going to go up here, lock it off, and you notice I can't really spiral up effectively anymore. But that's okay. As it turns out, this is just barely high enough for everything to work out just fine. So this is actually okay. And now we just need to stagger these, because, well, you can't place 2 spiral staircases directly next to each other if they're exactly the same. But if you stagger them up like that, like I just did, then everything works out just fine. I can bring this in a bit, like that. And sure, why not? I'll go ahead and build up a couple more blocks. It's about as far up as I think I'll need to go. Yeah, that's good. And cool. So these wires right here are going to be the 3 inputs to our decoder. And these spiral staircases are eventually going to become AND gates that will determine, well, which wire we're decoding to. So actually, I do have to build one more, I think. Or otherwise, this is, well, yeah, it's not really going to work. But that's okay. It's easy enough to do. Yeah, because otherwise the stacking would include this stuff that I did over there, and I don't really want that. So, yeah, just move a little bit further over, and now we should be able to stack this. So I'm going to set move this to position 1. And I'm going to fly... Okay, I'm going to fly over here. Perfect. Stack 2. Bam. So now we have 7 spiral staircases. 1 here, 2 there, stack 2 times, 2 times 7. And so it's great, we have 1 for each register, and now we just need to decode them. This is slightly complicated by some of the logistics of spiral staircase decoders. Most notably right here. The only real way we're going to be able to power this is with a repeater. So, pretty much no matter what, this puts a limit onto what can decode into what. I mean, intuitively, you want to decode register 1 goes here, then 2, 3, 4, 5, 6, 7, but obviously we can't do that, because 7 would require a bunch of torches. Only one of them matches up. And, yeah, not good. So, really, this seems like a bigger issue than it is. Because, really, which register here is register 1? Do we even care which register is register 1? Yeah, I don't. This register right here could be register 1. Or it could be this one. Or it could be this one. I really don't care, because all the registers act the same. As long as each register is unique, it doesn't matter which register is named what. So, we're going to do some... I don't want to call it register renaming, because that's actually a thing that some hardware does, but, you know, we're going to do some creative register naming. How about that? So this register, I think, is going to be number 1. So, whoops. It's only going to be off if this wire is on and these two are off. This is going to be a little bit odd to do, because I'm actually going to need to do this here so that I don't create an infinite torch powering block, powering wire. Yeah, don't want that. But this is good. This is what we want. I'm going to go ahead and put my blocks here, because, you know, why not? And actually, I'm just going to take a moment and figure out if there is a more optimal way of naming all these registers, just to make building these decoders a little bit easier. Okay, I'm back, and I've just done some interesting algebra in a spreadsheet. I've shown that aside from this top one right here, we can decode anything we want in these spiral decoders. So, really, it doesn't matter. Sort of. The part that doesn't tell you about is for some of the combinations, the wiring gets a little bit nuts. So, I've done a little bit of algebra, and I found what I think is the least crazy way of wiring this up. So, this thing right here, I'm going to go up 1 and block it off, and turn this into 1. And this is going to be decoder number 7. So, just like that, we have a 7, and we have 1. Keep that in mind. The other slightly weird thing is we're going to have to break this off, put a block here, and boom. So, this is going to be 6. So I'm going to put that here, and I can now power this with a repeater. Boom. We have 7 and 6. So now we're going to go to 5, and there should have been a way to do 5. Yeah, okay. I was thinking there should have been a simple way to do 5, but yeah, there is. There's 5? Hang on, was it supposed to be 5? Okay, this was supposed to be 1, then 2, 3, 4, 5, 6, 7. Okay. So 1, 2. Yeah, I'm having trouble remembering my own solution. It's always a good sign. So, okay. This is 1. This is going to be 2. So 0, 1, 0. There should be an easy way to do it, and there is. So 1, that's 2. 3 here. 1, 2. This 1, 2. Wait, 3 over here. Okay, I was wondering why that was looking a little tricky. So 3 over here. Yeah, a little bit easier to wire. 1, 2, 3. This is going to be 4, which we can wire pretty easily, like so. So, there. Perfect. So 1, 2, 3, 4, 5, 6, 7. So I actually broke these in experimenting. So now let's just make sure that everything is built correctly. We don't have any errors. So if I turn on 1, that turns off. And same thing over here for 2. And then 3 should skip 1. Good. 3. 4 should be next to 3. Good. And then we have 5 and 6. Good. And 7. Perfect. All of our decoders are working. Just like that. We are done. Alright, next thing on the agenda. We're going to change reading and writing for our registers to use our new decoder. Now the big thing for this is we're going to have a universal write command. It's going to write to all of our registers. Sort of. You'll see. So what I'm going to do is I'm going to just basically create some torches like this. So as long as this wire is off, we're going to be writing. And eventually we're going to hook the decoder up to the other side of this. I know it might seem counterintuitive considering our decoder's right here, but you'll see in a second there is an end game here. We're going to have it on the other side. And yeah, then everything should be pretty much good to go. And I'm going to turn this into a half slab. I don't think it actually changes anything, but I want it to be a half slab. So there you go. It's HPOS 1. This is HPOS 2. I'm going to expand 1 down, and I'm going to stack 2. So that almost writes to everything. We're still missing this guy. And we will need to add a few torches that I don't think got caught in our mix, but that's okay. Oh yeah, and we'll need to block this off. I'm pretty sure that's safe to do because... Whoops, excuse me. Yeah, oh, yeah, there's nothing in here that I really care about, so cool, we can just replace these like this, and once again, we're good to go. We just need to do a little bit of manual wiring. Okay. So cool. 1, 2, 3, 4, 5, 6, 7. Perfect. If I turn this off, we should stop writing to everything. If I turn this back on, we should be writing to all the registers again. Very cool. This is exactly what we're going for. Alright. Our next step is getting these decoders wired up to the registers. So what I'm going to do here is I'm actually going to have to change up the wiring a little bit. The reason for this is otherwise we won't be able to go down any farther with our spiral staircases without, well, causing a problem. So, whoops, yeah, this is pretty much unavoidable, but that's okay. From here, we can just keep going downwards. And actually, I think this is as far down as I need to go. I think I can do like this now. And perfect, we are heading under our new right wire, and we're good to go. I think the one next to it, though, we won't be quite so lucky. I think in this case, we're going to not be able to go down without a hitch. Okay, never mind, I stand corrected. We can go down without a hitch. Alright then. How about that? So I think I did something weird there by accident. I did. I accidentally went one backwards and spiral staircased down that way. Okay. Which... No, I couldn't change this back to being one up because then this would not go down far enough to dodge the wiring. So, yeah, but interesting. Okay. That was a little bit of an accident, but cool, it all works out. So great, now what I'm going to want to do is try and get a good position here to start stacking. I think this is a good candidate for each pass 1. And actually, I'll need to expand one that way, but that's okay. And this will be a good candidate for each pass 2. I need to expand 1. And let's try stacking 2 times. So, okay. We can break that. I don't need that anymore. I think our decoder is still set up correctly. It shouldn't... Yeah, there's no reason it should have been high enough to even have impacted that, so that should be 0. That's still 0. Let's just go do a quick check first. So that's 1. So 1, 0, 0, 1, 1. Is there anything in here? I think this might have deleted a 0 supposed to go here. So let's go ahead and replace that. And 1... Okay, so 1, 0, 1, 1, 0, 0, 1. Perfect. That's exactly correct. And now, all we have to do is go over here. And now, yeah, just like that. We do need to be careful to block these off, or else it's going to do a whole lot of writing. That's not what we want. But yeah, at this point I should just be able to do a quick HPass 1, HPass 2, probably expand 1 this way so that I capture the half slab, and stack... I think I can stack 6 times with... Okay, never mind. Okay, I guess I expanded 1 too much because I guess I accidentally had it over the half slab, alright. In any case, stack 6. Perfect. That's 1 too many. Okay, whatever. As long as it lines up with everything, which it pretty much seems to do, we're all good to go. Now, once again though, you gotta be careful, because otherwise, it'll delete those and not replace them. So, this is okay. This needs wiring back. I don't know why it's deleting everything like this. It shouldn't be, but yeah, whatever. This should be connected. And good. Now these should all be lined up with the respective reads. And they are. And it's good. If I pick a particular one of these, like number 1, all the way over here, is not... Ah! I have not yet made a spiral staircase for this very last one over here. Okay, and this one's going to be a little bit trickier. So, let's deal with this. And, actually, I just realized it won't actually be trickier, because you can do the same thing you usually do. Just go down like this. So, yeah, there you go. So no special arrangements or anything, just going straight on through. Excellent. Also, I just did a quick check, and I realized right here, where I used to have a torch like this, yeah, not actually powering anything anymore, so it's important to do a little divot and do like that, so yeah, everything decodes correctly. Okay, I went ahead and did a fairly tedious task off-screen. I figured out precisely how far we can take this wire and still make sure it will always have signal strength no matter what value is being decoded. And as it turns out, it's this far. Except for this wire. This one we can do one more, but I'm not going to be taking any advantage of it. So at this point, all we have to do is hook this up to the reads and the writes. So what I'm going to do is I'm going to, do like this. Invert, power wire, boom, going into the read. But you'll notice this isn't powering the write. And actually, before I forget, I'm going to put an inverted torch here, aka just a normal torch, and I'm going to say this is write. It's important to remember that when this wire is on, we're not writing. So yeah. And the way I'm going to get power to the write wire, you might think you could do something like this, and with some creative busing you could. You'd have to invert it again. I'm just going to do it here. So, and I'm going to use repeaters, and there. And at this point you're probably saying, okay, Benny, what is going on with you? This has just a ridiculous amount of delay to it. Exactly. That is the point, believe it or not. You see, when we read to a register, we're not going to want to write from it, or write to it, until the ALU has read the data, done its 6 ticks worth of processing, and now has the output that we're going to, write to. So this is the point. This delay will account for the ALU. And granted, the delay we have right now will not, but we're going to cross that bridge when we get to it, when it's a little bit more meaningful. For now, it's just going to be a slightly slower write command. So yeah, for this one, we have to do it a little bit differently. But the same general concept. Torch, 2 repeaters, and 2 blocks going this way. In this case, this means I'm going to have to block it off here in order for things to, work. But there. Now, this should not be like this. I should be able to... Yes. Perfect. And at this point, I should be able to do some creative world editing to help speed this process along a bit. That's HPOS1. If I fly over here and go down here, this can be HPOS2. And if I stack at least 2 times, I should be safe. Good. It doesn't include the uppermost bit, but that's okay. So I'm going to have to do a little bit manually, but that's alright. I've done manual stuff before. So I'm going to go over here. Perfect. And I'm going to fill in this one, which is just fine. I'm also going to have to fill it in for over here. So just like this. Because the wires, unfortunately, cannot be part of the world edit selection, or I would risk changing the registers, and I think I've had enough accidentally world edited out the correct functionality mishaps in this series, for the time being, at least. So there we go. With all of this in place, this should work as a complete read and write system. I should be able to say, pick register 1, just because I like register 1. And over here, cool, we're now reading from register 1, which has nothing saved to it whatsoever, but we're reading from it. And it can go through the ALU, and we could get something, let's say we get 8. And cool, now 8 should be going into register 1. Yes, it is, I think. No, it's not, because we haven't hit the write command. So now if I write, boom, we have written to register 1. Just like that. And now, look at that, we're reading the 8 back out. It's very cool. I can go ahead and break this, we don't need that anymore. Now I can write again. Boom. We've written to register 1 again, and we've got nothing again. So excellent, we now have a decoder system set up that immensely simplifies everything, rather than having 14 different controls to manage the registers. Now we have 4. The 3 to select which register, and this one to write it. So that's going to make the rest of our control unit just significantly easier. So yeah, that's all I wanted to cover in this video. Hopefully it's not too long. And yeah, thank you. Hope you enjoyed. Hope you learned. And I'll see you next time, where we're going to get a little bit more serious about the control unit. Greetings, it's Time Paradox Benny again. And I just noticed that a couple of the torches didn't get copied. I know. I literally cannot do any simple world edits without somehow breaking something. Oh well, maybe one of these days, right? Anyways, thank you. See you next time.